Hi everyone, welcome to CAIE Science, and today we will be solving May June 2022 paper 2-1 of A levels. So let's begin. Question number 1. Magnesium, calcium, magnesium and radium are group 2 elements. Radium follows the same trends as other members of group 2. Identify the highest energy orbital which contains electrons in calcium atom. Sketch the shape of this orbital. So if you write the electronic configuration of calcium, basically calcium has 20 electrons. This is calcium. There. This is calcium and calcium has 20 electrons. So the electronic configuration of calcium is going to be 1s2, 2s2, 2p6, 3s2, 3p6 and 4s2. So the highest energy level of orbital of calcium is 4s, and the shape of s orbital is, that it's oval shape. Okay, it's like this. Part B, write the equation for the thermal decomposition of calcium nitrate. So calcium nitrate decompose into calcium oxide plus nitrogen dioxide plus oxygen, and this is the balanced equation for this thermal decomposition reaction. Suggest which of the group 2 nitrates, calcium, magnesium or radium, requires the highest temperature to decompose. So it's going to be radium, because down the group thermal stability increases. And why that increases? Because uh, size of cation increases, so there is less polarization of uh, nitrate ion or anion, you can say that. So radium requires which so radium requires highest temperature, because because down the group stability increases. Part C, predict what you would observe when aqueous radium chloride is added to aqueous sodium sulfate. So when sodium sulfate reacts with radium chloride, this will form sodium chloride plus radium sulfate, and radium sulfate is insoluble because down the group solubility of sulfates decreases. So uh, radium sulfate will give a white ppt. So what you will observe? You will observe a white ppt, a white precipitate, precipitate, white precipitate. Okay. Part D, magnesium is an isotope of magnesium. Determine number of protons, neutrons and neutrons in an atom of magnesium 25. So number of protons are 12, because atomic number of magnesium is 12, and this is atomic number, and the mass number gives us nuclear number, and when we will subtract nuclear number from number of protons, so it will give us number of neutrons, and this is 13. State the full electronic configuration of an atom of magnesium 25. So here we have magnesium atom and it has 12 protons, so it means we'll have 12 electrons as well. So it's going to be 1s2, 2s2, 2p6, and 3s2. Okay. Party, the sample of magnesium contains three isotopes: magnesium 25, magnesium 26, and X. Okay, the percentage abundance of three isotopes is shown in table 1.1. The relative atomic mass AR is calculated by comparing the average mass of isotopes of an element to the unified atomic mass. Unified mass unit, sorry. So define unified atomic mass unit. This is the 1/12th mass of carbon 12 atom. Okay. Part 2. Calculate the mass of X. Use data from table 1.1 and AR of magnesium, which is 24.31 in your calculations. So how we will going to do this? So here you are given the masses of two isotopes and their all percentage abundances of all isotopes. So X is multiplied by 78, sorry, X has 78.99 percentage abundance plus 25. Magnesium 25 has mass of 24.99 multiplied by 10 percentage plus magnesium 26 has mass of 25.98 multiplied by 11.01 upon 100 is equals to AR, which is 24.31. So from here you will calculate the X value of X, and this is going to be X is going to be 23.99. 23.99. Listed one similarity and one difference in the properties of these isotopes of magnesium. So what are the similarities and differences? They have same chemical properties because they have identical electrons in outer shell. Okay. And which property is different? They have different physical properties because they have different number of neutrons. So identical, they have identical chemical properties because same electronic arrangement or configuration and different physical properties. Physical properties because different number of neutrons. Different number of neutrons. Moving to the towards next part, magnesium burns in oxygen. The activation energy for this reaction is plus 148. State one observation when magnesium burns in oxygen. Do not refer to temperature changes. So when magnesium burns, this burns with white flame. So white flame is the observation. Okay. On figure 1.1, sketch a reaction pathway diagram for the reaction that occurs when magnesium burns in oxygen. Label the diagram to show the enthalpy change and activation energy. So here you have to uh, understand that when magnesium reacts with oxygen, this forms magnesium oxide, and this is a combustion reaction, and all combustion reactions are exothermic. So this was the thing that you have to notice, that either you have to draw a activation endothermic graph or exothermic graph. So here we will draw exothermic graph, because this is also a bond formation, and when bonds are formed, energy is released. So this is an exothermic reaction. Okay, so here we will draw reactants, then here we will have products. So the products will be um, magnesium oxide, and the reactants are magnesium plus oxygen. Okay, and this is the activation energy. This is activation energy, and this is the enthalpy change. Okay, part G. Cold water reacts slowly with piece of magnesium to produce bubbles of hydrogen. Cold water reacts rapidly with burning magnesium to produce hydrogen in an explosive reaction, and the reaction is shown. Explain why rate of reaction of cold water with burning magnesium is greater. Because heat provides a greater molecules with energy greater than activation energy, so frequency of collisions increases. Heat provides molecules or particles. You It is better to write particles here. Heat provides particles with energy greater than and equal to activation energy, so frequency of collisions increases. Or you can write successful collision increases. This will be also right. Question number 2. Nitrogen molecules contain two atoms attracted by each other by a triple covalent bond. Describe how a triple covalent bond form a nitrogen molecule. Refer to orbital overlap and hybridization in your answer. So, how a triple bond is formed? One sigma bond. In triple bond, we have one sigma bond and two pi bonds, and this has a hybridization of sp in each nitrogen. So there is sp hybridization, and triple bond triple bond is formed by one sigma bond and two pi bonds. Okay, and how sigma bonds are formed? Sigma bonds are formed by head-to-head overlap of orbitals, and pi bonds are formed by sideways overlap. Okay, sigma bonds are formed by head-on overlap, and pi bonds are formed by sideways overlap. Okay, part B. Nitrogen oxides, nitrogen monoxide and nitrogen dioxide, are produced in an internal combustion engines. Release of these gases into atmosphere lead to formation of photochemical smoke. Outline how nitrogen oxides are involved in formation of photochemical smoke. So they react with unburnt hydrocarbons or volatile organic compounds to form peroxyacetyl nitrate, which is also called PAN. So they react with unburned hydrocarbons to form PAN, or you can write peroxyacetyl nitrate. Construct an equation to demonstrate how a catalytic converter reduces the amount of nitrogen oxide gases released into atmosphere. So in catalytic converter, nitrogen oxides are reduced to nitrogen. So this is done through carbon monoxide. Carbon monoxide is a reducing agent. So this reduces nitrogen to nitrogen oxides to nitrogen and forms carbon dioxide. So it's going to be like this. It is necessary to balance any equation. So uh, this also has marks sometimes. Okay. Part C. Nitrogen is very unreactive. It is difficult to make ammonia directly from its elements, but it can be made from ammonium chloride. Identify a reagent and conditions required to make ammonia from ammonium chloride. So when you react ammonium salts with any alkali or base and heat it, you will get ammonia. Okay, ammonium salts react with bases. So you can take any strong base, but the base should be strong. So you can take any group 1 hydroxide and group 2 hydroxide except magnesium oxide hydroxide. Okay, so I'm taking here sodium hydroxide, simple one, and heat is required. Okay. Part D. 25 cm cube of 0.1 mole per dm cube of HCl is added to a beaker and its pH is recorded. 50 cm cube of 0.1 mole per dm cube of ammonia is added to HCl in 5 cm cube portions. The pH of the mixture is monitored until all the ammonia is added. HCl is a strong Brownstein-Lowry acid. Describe what is meant by strong Brownstein-Lowry acid. So here strong means which fully dissociates into ions, and the acid means proton donor. So what will you write? Species which donate protons or H plus ions and fully dissociate into ions in the aqueous solution. Okay. Ammonia is a weak base. Construct an equation to show the behavior of ammonia as a weak Brownstein base when dissolved in water. So when water reacts with ammonia, this form ammonium ion and hydroxide ion. So here you can see that ammonia is acting as a base as it has accepted a proton from water, and water is acting as a acid because it has donated a proton. Okay. On figure 2.1, sketch a graph to show the change in pH which occurs when HCl is titrated with ammonia. So first you will see that what is the point of neutralization by seeing C1 V1 upon N1 is equals to C2 V2 upon N2. So we have concentration and volume of HCl, and in equation, if you write the equation, HCl plus ammonia, okay, HCl plus ammonia, they form ammonium chloride. Okay, so we have 1 mole of each uh, reactant. They are reacting in 1 to 1 ratio. Okay, so what was the concentration of HCl? 0.1 multiplied by 25 upon 1 is equals to 0.1 multiplied by x. X is how much ammonia, volume of ammonia is used. Okay, is required to neutralize. Okay, you can say that. So from here you can see that x is 25 cm cube, but we have used ammonia, volume of ammonia 50 cm cube. Okay, so 25 is going to be the neutralization or equivalence point. Equivalence point is going to be on 25 on x-axis, and the other thing is a what will be the equivalence point at pH, at which pH what will be the equivalence point. So this is the combination of strong acid and weak base. When you have a strong acid and a strong base, the this is 3 and 11, and the equivalence point comes in at 7. Okay, but this is a strong acid and weak base, so here we will choose this range, and this will have a equivalence point at 5. Okay, so now we can draw our graph. This is a strong acid, so we will draw from like this. Sorry, we will draw like this, and then you have also make sure that your pH should not increase than 12. Okay, so 13, 12, and I'm just putting a line over there so that my graph does not exceed 12, because ammonia is a weak base, so it will have a less pH. Okay, so here you can see that at 5 you have equivalence point. This is your equivalence point. Okay, question number 3. Liquid that contains molecule T smells like lemons. Molecules of T exist as pair of stereoisomerism. Name the type of stereoisomerism shown by molecule of T. Type of stereoisomerism. So if you see on the T, you can see there is a chiral carbon. Okay, and it also has a double bond, but it cannot exist as stereoisomerism because uh, you can see that there are same group attached on the carbon, okay, in the double bond. So it cannot show geometrical isomerism, but it can show optical isomerism because it has a chiral carbon. Okay, so which type of isomerism is shown? Optical, because it has a chiral center, and chiral center has uh, in chiral center carbon atom has attached 4 different groups. Okay, part B. Two organic products are produced when a sample of tea is heated under reflux with excess of acidified KMnO4. Okay, draw the structure of two organic products from this reaction. So when you react tea with hot acidified concentrated KMnO4, the double bond will break, and then you will have this molecule, this is ketone, and this double bond here will form acid, carboxylic acid, and this part will be the same. Okay, so what will be formed? It will form a ketone. Okay, and carboxylic acid group. Okay, like this. Okay, it will oxidize KMnO4 will oxidize T. Okay, this will also oxidize aldehyde group here. Okay, this will form aldehyde to carboxylic acid. Moving towards next part C. Figure 3.1 shows two reactions of T. Okay, and identify a suitable reagent for reaction 1. What is happening in reaction 1? The aldehyde group here is changing into alcohol, so it means it is reduced, and you can reduce the aldehydes by NaBH4, which is nat sodium borohydrate, and you can this is a reducing agent which can reduce aldehyde to hydroxy group or alcohols, aldehydes to alcohol. Okay, identify the reagents and conditions needed for reaction 2. What is happening in reaction 2? The double bond is converted into a single bond and OH group is attached, which means you have reacted it with steam. Okay, and when you react alkenes with steam, so what are the conditions? This reaction happens in the presence of catalyst phosphoric acid. Okay, so what are the reagent is its steam and phosphoric acid as a catalyst, and 300 degrees Celsius temperature and 60 to 70 atm pressure. Okay, these are the conditions to change alkene into alcohol. Okay, suggest which product formed in reaction 2 has a higher yield. Okay, so which alkene has a higher yield? It's going to be Q. And why is that? Because Q forms tertiary carbocation, and the tertiary carbocation is more stable. Okay, the hydrogen group is attached according to uh, Marconi Marconi rule. So it's going to be attached here. When double bond breaks, the hydrogen group will attach here and the OH will attach here. Okay, so Q will have a higher yield. Okay, so Q, because it forms tertiary carbocation, which is more stable. Okay, because more alkyl groups attach, so greater inductive effect. Okay, alkyl groups are electron donating groups. Okay, so this will form a carbocation like this. In Q we have carbocation like this. This is tertiary carbocation. So these all alkyls will donate electrons to C plus, so the charge density of C plus will reduce. And in R, you will have carbocation like this. You have two two alkyl groups attached. So these will also donate their proton electrons, but the charge density here will be higher than this one, because these all alkyl groups will donate this their electrons, and electrons have negative charge, so they will stabilize this uh, H plus positive charge. Okay, and here the charge density will be high, so it will be less stable than this one. Okay. Part D. Separate samples of Q and R are added to separate test tubes containing acidified potassium dichromate, dichromate 7, okay, and heated. Predict the observations for each test tube. Okay. By the way, this potassium dichromate has a color of orange, and when this reacts, it is an oxidizing agent. The color change from orange to green. Okay. Predict the observations for each test tube. Explain your answer in terms of functional groups present in Q and R. So when you react potassium dichromate, the these aldehyde groups in both R and Q, they will oxidize into carboxylic acid, and there this in R, this OH group will also oxidize into ketone. But in Q, the OH group will not oxidize, because you this is a tertiary alcohol, and tertiary alcohols can't be oxidized. Okay, so color change from orange to green in both test tubes. Okay, because aldehyde groups in both and OH group in R are all oxidized. So this is the reason. Okay, part 2. When PCl5 is added to separate samples of Q and R at room temperature, both react vigorously. Complete the equation shown in figure 3.1 to describe the reaction that occurs when R reacts with PCl5. So when PCl5 reacts with uh, R, this OH group will be substituted. Okay, PCl5 will substitute this OH group, and here you will this will be substituted by Cl plus POCl plus HCl. Okay, moving towards next question. Part 3. Suggest why samples of Q and R must be dried before PCl5 is added. Include a relevant equation to support your answer. It must be dried because the PCl5 is hydrolyzed in water. Okay, it reacts with water to form phosphoric acid. Okay, so what is the reason? Water water hydrolyzes PCl5. Okay, and the equation for this reaction is water reacts with PCl5 to form phosphoric acid, and HCl. This equation is also correct, and if you write this equation, if PCl5 reacts with water and this forms POCl3 plus 2HCl, so this equation is also correct, but I would suggest you write this equation because uh, in a hydrolysis reaction PCl5 is converted into phosphoric acid. Okay. Question number 4. Compound V is a liquid. V contains 77.2 percentage of carbon and others. V has a relative molecular mass of 280. Calculate the molecular formula of V. So first we will calculate empirical formula, then we will calculate molecular formula. So carbon, hydrogen, and oxygen, 77.2 percentage and 1.1 and 11.4. Okay. So we will firstly divide these percentages by their atomic masses. So carbon has a mass of 12 atomic mass and hydrogen has 1, oxygen has 16. So this will give us 11.4 and 0.712 and 6.43. Okay. Now we will divide these all with the number which is smallest. So here 0.71 is smallest of all. So I am dividing it with all of the numbers. Okay. So here we will get 9, 16 and 1. Okay. So the empirical formula is C9H16 and O. Now the molecular formula is calculated using molecular mass divided by empirical mass. So molecular mass is 280, and if you calculate the empirical mass, so carbon has, there are 9 carbons, so 9 multiplied by 12 plus hydrogens are 16 plus there is 1 oxygen. So this gives a total mass of 140. Okay, so 2 is the answer, and now you will divide 2 with the empirical formula. Okay, so C18 H32 and O2. So this is your molecular formula, C18 H32 and O2. Part B. V contains two types of functional groups, carboxylic acid and alkene. Okay, describe a chemical test and observation which will confirm the presence of carboxylic functional group. Okay, so there is acid, and if you react an acid with carbonate, any carbonate, so you will acid reacts with carbonates to form a salt and carbon dioxide. So carbon dioxide will be observation which when you the carbon dioxide is added to lime water, the lime water is termed milky. So this is the observation. Okay, so what will you write? Add, you can write any carbonate, add sodium carbonate and effervescence will be observed. Effervescence will be observed, or you can write lime water turned milky. Okay, you can write that as well. 3.196 gram of sample of bromine reacts completely with 2.8 gram of V. Okay, calculate how many alkene functional groups are present in one molecule of V. So you are working. Okay, so you have to calculate moles of V and bromine. So I'm calculating first mole of V, which is 2.8 divided by uh, molecular formula of V, which is 280. So this is going to be 0.01. Okay, and then you have moles of bromine, 3.196 divided by mass mr of bromine, which you will calculate using periodic table. In periodic table you have AR of bromine 79.9. So 79.9 multiplied by 2. Okay, so this will give you 0.02. Okay, 0.02. So from here you can see that 2 moles of Br are reacting with 1 mole of V. So number of alkenes in V are going to be 2, because with one alkene 1 mole of Br is reacted. Okay, and when there are 2 double bonds, then 2 uh, moles of bromine will react. Okay, part C, W, X and Y have the same molecular formula, C5H10O2. O, sorry. W, X and Y are added separately to different reagents. Observations for these reactions are described in table 4.1. Okay, W, X and Y each contain a common functional group. Name the functional group that is present in all 3 compounds. So from observations you can see that these all give orange precipitate with 2,4-dinitrophenol hydrogen, and this is the test for carbonyl group. So these all give a positive test. So this means they all contain carbonyl group. Okay, state the formula of yellow precipitate produced when X is added to alkaline iodine. Sorry. So the yellow precipitate, this is the test for methyl group, and the yellow precipitate form is triiodomethane, and it has formula of CHI3. Okay, this is the yellow precipitate. W could be one of 4 structural isomers. Okay, W. Draw the skeletal formulae of 2 possible structural isomers of W. Describe the type of structural isomerism shown. Okay, so W is an aldehyde because this gives a positive test with Pelling solution, and this aldehyde is not attached to a methyl group, so it does not give a positive test with iodine. So firstly, uh, you have the molecular formula of C5H10O, and this is an aldehyde. For suppose this is W, so you can I'm drawing the 4 possible structural isomers of this. So these are going to be C. This is the first one, simple one, and the second one is going to be a branched isomer. Okay, like this is your second isomer, third isomer, sorry. And your fourth isomer, further branch it, and this will give you 2,2-dimethyl propanol. Okay, so these are your four possible isomers of W, and you can draw any two of them. So I'm drawing the simplest one first. Sorry. And then like this. Okay, 1, 2, 3, 4, 5. Okay, so these are the structures, and you can draw any of these structures. These are the structural isomers of W. And what is the type of structural isomerism shown? So this is chain isomerism. Chain. Okay, chain isomerism is shown. Part D. Figure 5.1 shows the mass spectrum of ketone Z and Z. This uh, this list does not contain Z. Okay. Use the information in figure 5.1 to suggest the formula of the fragments mass to charge peak of 29 and 57. Okay. This is the identity of Z. Okay. So in the mass spectrum, the peak at the end, the one with the highest mass to charge ratio, this peak, and in all mass spectrum, this peak is the molecular ion peak, which gives the MR. So you can see here that the ketone Z has the MR of 86, and this peak is also at 86. So this is the molecular ion peak. Okay, 86 at 86. And then we have peak at 57, and then we have at 29. So if you divide 86 from 57, so you will get 29. So means 29 is the MR molecular formula of CH2CH3. So means an ethyl group is eliminated. Okay, at 57. So this 57 peak is given, and then when you will divide 86 from and so you will subtract 86 from 29, then you will get 57. So first I would say you should have drawn the all possible isomers of ketone Z. So here we have C5H10O, and if you draw possible isomers CH3, CH2, C double bond O, CH2, and CH3. Okay, then second one CH3, C double bond O, CH3, CH2, CH2, CH3, and then CH3, C double bond O. Then draw a branch CH, CH3, and CH3. Okay, so here if you see here, first one, if I eliminate this 29 group and break the uh, compound here from here to 20, So this 29 group is eliminated and you will get this sign. Okay, and if you calculate the MR of this, you will get 57. So the peak at 57 is due to this sign. Okay, and then if you eliminate this one, this is 57 and this is 29. So if you eliminate 57, then you will get a peak at 29. So peak at 29 is due to ethyl ion. Okay, this is ethyl group. So you can write it as C2H5 plus. Okay, so this means you have this molecule of this ketone is pentane 3 on. Okay, and why you can't have 2 and 3? Because if you break the molecule from here, you will not get 29 or 57. Okay, you can check this out. Here you will have uh, 29 plus 12 plus 14, 12 plus 2 is equals to 14, so you will get 43. So this is 43, and then if you divide 40, subtract 43 from 86, you will get 86 minus 43 and you will get 43. So this is also 43 and this is also 43, but we don't have any peak at 43. And here is also another reason. Okay, no, okay, okay, no. So this can't be the Z, and this also can't be Z, because if you break the your compound from here, you will get 43 and 43. Okay, so no peak at 43, and if you break from here, this will also not give you the peaks, and this will be the have a peak at 15, but you don't have any peak at 15. So there is only one compound which is giving us the exact peaks, and which is pentane 3 on. Okay, so peak at 29 is due to C2H5 plus. Okay, this is ethyl group, and the peak at uh, the peak at 57 is due to this group. Okay, you can write it as COCH2CH3 plus, or you can write it as uh, C3H5O plus. Okay, and this Z is pentane 3 on. Pentane 3 on. Okay, so there your paper is finished. I hope everything is clear to you. Thanks for watching, and do subscribe the channel for the upcoming papers. Thank you for watching, and see you in the next video. Take care and goodbye.